All right, hey everyone, welcome again to day 2. Today's topic will be Shadow DOM and CSS in general. Before we get to the Shadow DOM in particular, I want to take a step back and talk about how we work with modularity in CSS before this whole web components thing. Just a reminder, this is the URL. If you don't have it, this is the URL for the live, so you can follow along. All right, so we're going to talk about modular CSS patterns. And so any of the Shadow DOM stuff we did yesterday, just sort of like put that to the side in your mind for now. We're going to come back to that, I promise, this afternoon. It's going to be all Shadow DOM. But knowing what we know now about the problems with encapsulation in CSS, the problems with scoping or lack thereof, and the things that Shadow DOM seeks to solve, let's talk about how this was done before Shadow DOM. Because websites existed, and they have existed for with CSS for a long time, and they've done quite well. I mean, there have been challenges, but we've found ways to overcome them. And so the key to being able to overcome those challenges is this idea of modular CSS patterns. The patterns is the important part. Or subtitled, How Not to Make Your CSS Feel Like This. Sometimes this is how CSS feels. We're just constantly fighting with it. All right, so the dark side of the cascade. CSS is great, and it gives us this power for building out very styled websites, sites that didn't exist before CSS. But there are problems with it. There's no scoping in CSS. There's no encapsulation. Scoping and encapsulation is different. They're very related, but they're different, so I just want to keep that in mind. Scoping is the ability to scope styles to a particular module or a component, whereas encapsulation is the ability to only reveal certain things to other components. That information hiding, think encapsulation, think hiding in terms of hiding the inside mechanisms. And then portability. There's no good way to make CSS portable, as we learned yesterday. While we have a way to transport it, right, we can't just arbitrarily insert it into our document and expect it to work. It relies a lot on order, it relies a lot on context. And these three pieces are kind of the key shortcomings. So there are a few tweets that I think were very insightful on CSS. This is from one of the creators of React.js. This isn't specific to React, but they're doing a lot of work in the CSS space. And so I think this is really interesting. The problem with CSS are selectors. Right, that's the key part of CSS, but it's also the problem. They let you arbitrarily modify anything from any file. They're bad at scale. And bad at scale is important, right? Like, as on a small scale, we can cope with them, but as things start to get bigger, it's a lot more challenging to deal with those CSS selectors. And kind of a follow-up there, CSS selectors are like having globals all over your code. Yes, in the short term, it gives you a quick win, right? And we know this when we're learning JavaScript, right? I think when we first start writing JavaScript, we write globals everywhere. Like, we just put everything in the global namespace, and we get the quick win from that. It's easy, right? We can access anything from anywhere. Cool. We can modify anything. We really very quickly start to realize that that's not sustainable. That becomes very problematic. We have namespace conflicts. We have components interacting with components that they're not supposed to. We have pieces of our code stepping on other pieces' feet. I mean, that's part of the problem. And so at first, I think it seems like, oh, that's fine. Those globals are all right. But we end up, as things grow, it becoming quite a bit of a problem. And we end up struggling with our CSS. CSS is globals everywhere. There's no inherent scoping in CSS. And this is the challenge. This is what we have to figure out a way around. CSS rules are order dependent. We can't just throw our modules anywhere and expect them to work like we could, for example, with JavaScript. They're very dependent on how they're ordered. So how can we add some modularity? How can we do this without web components, without Shadow DOM? How can we do this with technologies that we have available today or available 5 years ago? How does that work? And the answer is architecture patterns. I think, in the absence of the actual technologies, developers find a way around the shortcomings of a technology. We're very good at doing that. Yeah, I mean, this idea of like hackers, right, is that we can make technologies do things that they weren't originally intended to do. That's the whole idea. And so we find patterns that allow us to achieve goals that we're seeking to achieve. And this idea of architecture, I think, is very important. How can we find a model for what we want to achieve? How can we bring order to the chaos that exists in this particular technology in CSS? So in the absence of the technology support, the out-of-the-box native support for this modularity, we're going to figure out a way around it anyway. And we have. Over the years, we came up with different patterns that we can use to achieve modularity in CSS. There are four big ones that come to my mind. We're going to focus on the top three here because I think they're most helpful in terms of modularity. And I'll touch briefly on this last one, Atomic CSS, as well. But they're OOCSS, BEM, and SMAX. All right, so we're going to focus on these three. Let's start with OOCSS. OOCSS is Object-Oriented CSS. That's what it stands for. It was created by an engineer, Nicole Sullivan, when she was working with Facebook, and she actually talked about this pattern that she kept seeing over and over again in CSS code. She has a blog post that's really kind of the start of OOCSS, and it's sort of hard when you Google OOCSS. This blog post doesn't always come up at the top, but I think this was one of the key ones. And it's back in 2010, and it's that the media object saves hundreds of lines of code. And she noticed that in Facebook, we repeated the same pattern over and over again. Like, we constantly have this image and like text or something else, right? We have these two things next to each other. We have image, something else, image, something else. And it was being implemented in different ways, but it all could be boiled down to this. It all could be generalized. We could find a general pattern between these repeated UI elements we saw on our page. And so she has this diagram where she sort of scopes out, does that paper and pencil componentization that we did yesterday, and figures out where are the repeating components on this page. Like, this is actually a very repeatable pattern. And that pattern happens over and over and over and over again, all throughout Facebook. This is that key idea of OOCSS, is that we find these repeatable patterns and we treat them as objects that we can reuse throughout our application. So what does the CSS actually look like? Before we go into that, let's go back to that blog article. Saves hundreds of lines of code. I think this is the key point of OOCSS, is that we end up in CSS writing things over and over again, and we write very specific code when we can actually generalize things. So in OOCSS, you want to keep that principle in mind. So how have we generalized it here? We've said .media, that's our media object. And then we have specific descendant selectors here within that to do the positioning and do the margins. And that's how we were able to reduce those many different patterns down to a single, 1, 2, 3, 4, 5 selectors, 4, 5 rules, 5 rules in CSS. And there may be a few more that need to be there. And there are certainly ways to extend that. So we can take these 5 rules and extend them as we need for things that are different. Maybe there are particular features of these media objects that have text inputs in them, or different content on either side. But for the most part, OOCSS boils down to being able to generalize these patterns. And there are 2 main principles that she talks about. The first one is separating structure and skin, and the second one is separating container and content. Structure and skin, container and content. So the first piece here is that when we look at our structure of our component, we don't talk a lot here about, maybe there's a border, or maybe something's colored blue, or something that just sort of skins over the object. We're going to focus on the structure first. That's the important piece. And then container and content is particularly important. So there's definitely different styles for this paragraph in here, and there are different styles for a few seconds ago in this link. That's fine. Those will be handled independently, and we'll treat the container as a independent component, and then put our content in there and treat that as something separate. So then we can generalize the container from the content. And I know these are a little bit like, especially with OCSS, these rules are a little fuzzy, and they're more principles than anything. And so OCSS is interpreted in a lot of different ways, and that can be a little bit challenging to, like, how am I going to make this OCSS, right? People implement that idea in different ways. But we take those principles and dive into them further. I definitely recommend taking a look at Nicole Sullivan's presentation here on object-oriented CSS, and she dives into some of the related principles on this a lot more. That's OCSS. All right, the next one is SMACS. SMACS stands for Scalable Modular Architecture for CSS. It was written by Jonathan Snook, and I highly recommend going to his website and checking out. He has an ebook available there, and a lot of it's free on the website about what this architecture looks like. And SMACS, I think, takes a lot of suggestions from OCSS in how we build out our CSS on our pages, but it's a little bit more structured. While OCSS provide the principles, SMACS give us a little bit more direction there. SMACS came about when Jonathan Snook was working on Yahoo Mail. And so what I think about here is interesting is this isn't like a content site. This is very much like an application, right? It's one of the early web applications. And so Jonathan found that there were 5 different key categories of styles, and that these categories were how we should organize our CSS, and this will help us to provide modularity. So we have our base styles. These are things like our resets, our styles that we want everywhere on our page. Maybe our defaults, like a default color for a link. So resets, defaults, these are going into our base, things that we want kind of at the top of our document to be shared everywhere. Then we have our layout styles. This is actually an example from Bootstrap Grid. So layouts are how we display things on the page, and a large part of layouts, I think, are how we use grids. I think grids are a vital way of being able to separate that container that we have on where we want these modules on our page to go, and then our individual components that we can put within the grid. And so in SMACS, the grid goes in that layout section of styles. You don't have to use a grid with layout. With SMACS, I think you could apply these layout styles in different ways, but any sort of styles that are meant for the laying out of your page would go into layout. And then we have module. Modules are probably what I would describe as components. They're these individual blocks on the page. And so I'm calling this module a module, but it could easily be called anything, media object or something like that. And there's going to be any of our different styles here, and we're going to use descendant selectors to change things. So there are a couple pieces I want to call out here. There's not much in this particular module. This is one that he uses on his website as an example, so I wanted to use that particular one. But first is having the entire block as 100% width. So having our module as 100% width means it can fit into any container that it's put into. Again, one of these principles is separating container from our content. And so it can fit into any container. That container could be a grid, it could be some other layout, it could be some other module, but it fills that width. It's, at this point, context independent because it allows the context to dictate how wide it is. We also have descendant selectors. So descendant selectors are when you have a space in between here, and descendant selectors are preferred a lot of times to child selectors. Child selectors have a greater than symbol, and the reason those are helpful, so with child selectors you need to be the immediate child of your parent for the selector to work. So if input were somewhere or nested down, that would be a problem. The problem there, of course, is that if you add a div in somewhere into your module, you're going to start breaking CSS because it's very tied to that connection, that parent-child relationship between elements, And so you can't just add a div somewhere and expect it still to work. Things would start breaking. So descendant selectors are helpful there to avoid that brittleness. On the other hand, child selectors certainly have the added benefit of not being as susceptible to the nesting problems we saw yesterday, where you can have styles inadvertently go down the DOM tree. And the last piece is this full thing here. So we have module, and then we have module full. And so this is just a modified version of these modules. So this you would put onto a div that also had the module class. So you would have module space module dash full in your class attribute. And now you would be able to override this style here with 100%. So in this case, we wanted our input to be 100% with, our module is still 100% wide, that's different. But in here, our input is wider. And that modifier is what gave us that ability. So one of the things we have to think about with modules is that we're always going to want to modify them. We're always going to want to extend them and have either different states or different modifiers. Speaking of state, we have the next piece here, which is how we can do state in a module. So state is something that we constantly see in our CSS components. And if we want to highlight some sort of transient state in our component. So for example, we might have a menu, and we have a set of list items in the menu, and one of the list items is active, and the other ones are not. But that's not permanent, right? We know we're going to remove that active attribute as soon as it's not active, and then we might add it in later. Similarly, we might have a block that's featured, and it's supposed to look like the other blocks, but this one just happens to have a border around it, or something like that. And so in this case, we want to distinguish these state rules. So we have our normal module, and then we have a module is featured. And now I can just add this module is featured class onto my module, and I can control that state. I can override the existing styles of that block. And so in this way, we have a nice bit of extensibility. We have a nice way to extend the current state of our CSS, our styles in a particular element. And the last piece is theme. Theme was sort of unique, I think, to how Smax was developed in the context of Yahoo Mail, because there was this need to be able to develop different themes for your mail. I think we still have this feature in Gmail, but you can you have an application where you can sort of reskin everything to the user's preference. So maybe you want to change it to a dark background as opposed to a light background, or you want it to be full width as opposed to kind of fixed width and centered. So you want this ability to theme everything globally, and you don't want to have to duplicate everything, at least not in the client. And so in this case, we have two different CSS files. We have a main, we have a theme, and the theme overrides the main. So here we can either deliver a separate style sheet entirely, or I think the kind of general use for this would be to include main and then have a specific theme that overrides main. So in this case, you'd only include the theme that you needed for that user. So on the server side, you decide, what link tag am I going to include on the page for the theme overrides. All right, so that's Smax. Let's talk about BEM. BEM is probably, I think it's the most interesting of the three. Not sure why I left it for last, but we can talk about why that is. So BEM is called Block Element Modifier. It's often called the BEM methodology, Block Element Modifier methodology. It was created by Yandex. Has anyone heard of Yandex? All right, so we got a few. You may not have, because it is a Russian search engine. So if you were in Russia, maybe you'd be familiar with it. This isn't as familiar to us, but it's the biggest search engine there, and it's a pretty big company. And Yandex actually has an active role in shaping web standards. So they've done a lot of really interesting work. And I think actually the best way to understand BEM is to go to Yandex and open up the source and look at the code. This is one example of sort of eating your own dog food. We're being very, using the technologies that you talk about in a very visible way. So if I pull up the source here, let me see if I can. It doesn't let me zoom in on the images, but if you're looking at it on your computers, you can probably see it a little closer. So we have a div here for news up at the top, and it says div class b-news. Then I have some accessibility labels. We'll talk more about accessibility later this week. So b-news. And the next line is I have b-tabs. Then I have i-bem. Then I have b-tabs underscore. Oops, there we go. Oh, there we go. I have a slide that highlights. underscore head, b-tabs underscore head 2. So we see these patterns are sort of repeating, and they look kind of cryptic. But they're very systematic. Like, I think if the thing that I take away from this, just looking at BEM for the first time, is there's a very clear set of patterns that's happening here. This doesn't seem arbitrary. So you're not just making up random names. There's clearly a system. There's prepending these things with B. There's this dash, this hyphen character that we have. There's these double underscores. There are a lot of these repeating patterns that seem to have a role. So what's a block? Block element modifier. A block is an independent entity. This is how BEM defines it themselves. It's an independent entity, a building block of an application. It can be either simple or compound, containing other blocks. Independent entity, that's how we understand a block. Kind of the small pieces that we use to build up our page. Element is a part of a block that performs a certain function. So blocks have elements. Elements are context dependent. They only make sense in the context of a block they belong to. Whereas blocks are context independent, elements are context dependent. Elements depend on the block that they're in. They're you can think of them as sub-elements of a block. Then a modifier is a property of a block or an element that alters its look or behavior. So a modifier is going to alter something that's either an element or a block. And understanding these definitions is very important with BEM. It's very important that we're very clear about how these work. A block is context independent. It can be simple or compound, so there can be other blocks. An element is context dependent. It only makes sense in the context of its block. And then a modifier is a property of a block or an element that alters its look or behavior. So these are examples that BEM provides on their website, and they're really helpful for understanding how we use BEM. So let's take a basic website. I have like a search box up here. We have a login, logo, some content, and a footer. We have some tabs up here as well. So how do we separate this into blocks? So BEM, we would start to do that paper and pencil componentization here, and we would start to see where are what we called components yesterday. BEM is calling blocks. So these are blocks that are context independent, and they can be simple or compound. So let's take this header here. We could certainly call that one entire block. We call it our head block. And then we have blocks individually within here. These are not elements because they are context independent. I can take this authentication block and move it wherever I'd like. I could, for example, move it to the footer or move it to a sidebar. I could take this search box and move it anywhere. I could take the menu block, the tabs up here, and move them anywhere. All right, so if search is a block, how can we drill down deeper? So BEM actually takes a step beyond and says, well, there are elements within this block. So in this case, this is a single block with two elements, specifically the input field and the search button. Because the argument here is that these individual elements can't exist outside of the search block. That it wouldn't make sense to have a button independent of the search field or a search field independent of the button, at least in this component. And so these go together. They're inherently tied together by their block. In the same way, we have our menu. So our menu is entirely a block. We have our tabs in our menu. But each tab is an element. It really wouldn't make sense to have a tab on its own. Those are dependent on the context. There's a quote that always comes up over and over again. There are only two hard things in computer science: cache and validation, and naming things. Cache and validation is actually tricky with CSS, but naming things is something that we wouldn't think would be difficult, but it is. BEM does a really good job at naming things. BEM is really all about how we name things, how we talk about things, the language that we use to describe things, both in the general sense, blocks, elements, modifiers, but also when we name these individual blocks, we name these individual elements, we name these individual modifiers. And that's the really important piece of BEM, I think, is being smart about the names that we choose and how we describe the styles that we have. So let's take an example. We have a div with a nav menu. This is a block. We're doing some sort of nav menu here, and we want it to be a block. With BEM, you got to figure out some sort of differentiator, some sort of delimiter between words. And you also have to figure out delimiters between blocks and elements in class names. And we'll demo that here. So if we have a nav menu that's a block and we have the items in the menu that are elements, we need to be very clear in the name of the class what part of that name is the block name and what part of the name is the element name. And so in BEM, we have 1 underscore here for the block name, and then we have 2 underscores for the to delimit the element name. Now, BEM is not strict about what delimiters you use. You can use whatever delimiters you would like. They're very clear about that. I don't actually like underscores that much. I think like hyphens look better, so I can do that. However, BEM is strict about using some sort of consistent form of delimiters. That's important. It's specifically machine readable. You need to be able to process this, say with JavaScript, and be able to pick out which parts of your application now are blocks and which part are elements. And so you need to figure out some sort of consistent naming convention.
This is just to provide some code organization, so when you're looking at your style sheet, you can be like, okay, here's my block, here are the elements in it, just by the way things are named.
Yeah, there's that human aspect of it. But with BEM, they actually take it to the next level. So because it's machine readable, BEM actually provides programmatic tools to be able to figure out the structure of your application based on the naming. So they actually have tools where you can run, so we have document query selector, right, for selecting elements directly. And BEM has written libraries on top of that, that instead of selecting elements directly, you can say, select me the block named nav menu. And you'll be able to select that block because BEM knows your naming convention. You can put it into your JavaScript configuration. And you can say, well, I know that this is going to be separated with an underscore. And I also know to ignore, for a block, anything that has an element on it. I could say, get me all the elements within a nav menu. And then it could go ahead and say, well, I found nav menu. And then I found 2 underscores with item after, and I know that's an element. And so when we're very consistent with this naming, you can actually, it opens up a lot of doors for programmatic access to that structure of our application. Essentially, it gives semantics in the context of BEM to the structure of our components. All right, so the last piece is modifiers. So before we go into modifiers, I do want to call out here, you'll notice we're not using 2 classes for this. In SMAX and CSS, we tended to use multiple classes and then use descendant selectors to style that. We're not doing that here. We're actually using a new class, and we're using the naming to enforce the relationships. BEM does that to avoid a lot of the nesting problems that we normally see and a lot of the specificity problems that we see with something like CSS or SMAX. In CSS, as you add more selectors, right, we make more specific rules. So as we add descendant selectors, the rules become more and more specific. And so we get to a point where some of our rules are more specific than others, and we're sort of fighting over the specificity there until we get fed up and put an important on the rule because we can't override it. BEM avoids that by saying we're going to keep our selectors as shallow as possible. And with BEM, that only has to be 1 or max 2 selectors. We'll show max 2 with modifiers. But you only need one class selector if you're styling either an element or a block. You only have one, and you know it's part of the nav menu still because of the naming convention. Additionally, what the naming convention gives us here, and you might be thinking, well, this is a lot of writing to do. Like when I'm writing out my CSS and I'm going to have individual selectors for every item here, when maybe I could just use descendant selectors. BEM also has tooling to help you avoid that. So they have tooling to allow you to be smart about not writing too much in your CSS source. How many of you use Sass? You guys use Sass during the CSS section? Cool. So Sass actually has a plugin. There's an extension in Sass for BEM, and there's some ways that you can use Sass to avoid rewriting all of this. Sass is really nice for just like doing these nestable structures for descendant selectors. The problem is you can very quickly overnest in Sass, and so you very quickly might start nesting everything in Sass, and it might look great from the source, but then when you actually compile that down, you end up with very long descendant selectors, and you have the same inheritance problem you had before. You don't want to do that with BEM, but you do want to take an approach that kind of makes it look nice. So with Sass, there's a method to do string interpolation for adding on these kind of prefixes for your blocks. All right, so once we add a modifier in, things change a little bit. You can go ahead and add a second class here. But again, we're going to name our modifier very specifically. So our modifier only has to change the things that it needs to change from the element or the block. Remember, we can have modifiers. This is the modifier, by the way, the active. We can have modifiers in both the block or the element. In this case, we have it on the element, nav menu item active. We have a different delimiter here to tell me that this is a modifier. And in fact, programmatically here, I know that this is a modifier for an element because that's underscore underscore item dash active, as opposed to just having a block name dash active. So I can now figure out that this is a specific kind of modifier, and I know how it's going to work. And I define it as such in my CSS. Yes, that's it. All right. So BEM has some words of wisdom here. They strongly suggest that it's important to use separators consistently to allow tools and helpers unambiguous programmatic access to the elements. So there can't be any ambiguity here. There can't be any ambiguity when you look at nav menu item active in thinking, is this a modifier or is it an element? Because remember, the order in CSS classes don't matter, like in how I do this attribute. They only matter in how they show up in the CSS. So I don't know that this is the element and this is the modifier just by their order. I know it by the naming in BEM. All right, so those are the three major architectures that we developed for doing modular programming in CSS and kind of getting around some of these problems that we have with modularity built into the language. There are common themes between all of these, and I think that's the important part as well to pull out here. If you're not going to adhere strictly to BEM or SMAX or OSCSS, I think it's more important to look at the themes between all of them. There are four that I noticed in particular. The first are shallow selectors. This idea that specificity is problematic, and if we can reduce specificity in our CSS selectors, it's easier to reason about these selectors. It's less difficult to deal with the inheritance problems or the specificity problems that we have between modules. The second is namespacing.
So what are shallow selectors?
So it's keeping, I'll demo, that's a good question. So the question is, what is shallow selectors? And I'm going to go ahead and demo that. So if I have my component and I have some styles, let's say color. Okay. So sometimes in CSS, selectors start like this, right? But we very quickly start writing other things. Modified component, another we'll have another class here, so this is not a shallow selector. So now we have multiple parts of the selector. We have one class, a descendant selector for modified component, a descendant selector for another, a selector for foo, so a nuller has to have the foo attribute, and then we have div, so descendant for div, and then we have, just for fun here, I'll put another combinator in. So we have a child selector for a link, and there are a couple problems with here. One, it's very brittle, so if this changes at all, if we remove a div, say, now this entire thing breaks. It's also very specific. So this is going to override something that's just my component A. Now we're going to have a specificity issue because we have more. This is a more specific selector, and so CSS is going to give preference to this.
So 1 is more shallow than 4.
Yes, 1 is more shallow than 4. And so all of these patterns tend to recommend the most shallow selectors that you can get. BEM probably gives us the ability to do even more shallow selectors to the point where most things, with BEM you might have a nav bar, and then you would have like a nav bar item. So let me say BEM, I'll just say shallow selector example, and then so whereas with something like SMAX or OCSS or a loosely defined version of those, you might have nav bar item. And so it's certainly the case that these two selectors, you would probably have two here, so let me just bring that up. So if we wanted to style both our block or our equivalent of our block in BEM and then SMAX or OCSS, we would see this difference where we have in BEM ideally for both the block and the element we're only going to have one selector, whereas with SMAX and OCSS there's a little more wiggle room there in terms of this is okay using a descendant selector there. So BEM is always going to be more shallow, which is going to avoid the issues that we see down here. And this is, again, sort of a contrived example, but I've certainly seen code like that.
All right, so just curious, but when you have right there, yeah, and this is the tangent, but that says any anchor that's a direct child of a div that is inside of something that has a class of foo. What does it mean when you push the classes together? You got to class another.
It means that you have to have an element that has both classes.
Okay.
So it'll have to have another and foo as opposed to a descendant selector, which is a child element.
And then that would all be a descendant of something that has a class of modified component, which would be a descendant of something that has a class of my component.
Yes. So yeah. The point that was just made for was
Back in your words.
yes. Is so one of the problems with this actually is that it's hard to kind of understand what's going on. Right. You look at this and there's a lot of pieces of this. But so if we start here at the link, a link has to, the anchor tag has to be a child of a div element, which has to be some level child, a descendant of an element that has two classes, another and foo, which has to be a descendant of an element that has the class modified component, which has to be a descendant of a element that has the class my component.
I like your description of brittle.
Yes, it is very brittle. That's the point here. We want to avoid that. And so when people have been developing these different CSS methodologies, I don't think it's an accident that we've come out with patterns that emphasize shallow selectors, that emphasize not having these very specific ones. Because even just beyond the brittleness here, it is now very difficult to override this. If I want to override this for whatever reason, say I want to add a state onto here, now I gotta take all of that. If I just want something that has state, Now I either have to override it that way, or like I could take the easy way out, which is what people do, and this is why it's problematic. And I'll say color blue, I'll say important, right? And now I hope that that's important. Will that give me some weight, and I'll be able to override that that selector. And so, and this is where sort of that the comical animation with the blinds comes into play. Is that it sort of feels like you're just changing things until it finally works, and that shouldn't be the case with programming, right? You should be able to know how it's going to work, but even with CSS, after like years of doing it, it's hard to predict how it's going to work. All right.
Are you close, or shall we drop?
Yeah, no, I'm close. So, no, that's all right. All right. The next kind of feature I found is namespacing. There's this idea of namespacing our components, our modules, as we build them out, and whether that be with a descendant selector, putting one class at the top of our component and having selectors underneath that, doing the namespace that way, or with BEM, with the actual naming of the class itself, or with the single class, you have some sort of way to name these components. The next is reuse. It's keeping our code dry. How many of you heard the term dry? So dry means do not repeat yourself, or don't repeat yourself. And so in general, we want our code to be dry. We don't want to have to repeat ourselves. We don't want to be writing the same thing over and over again. The goal of abstraction in programming is to generalize as we start to repeat ourselves. So to identify when we repeat ourselves over and over and over again, generalize it into say, a function in JavaScript, or something that we can reuse. In CSS, that might be a particular rule. So the media element, the media object in Nicole Sullivan's example in OOCSS is a good example, I think, of being dry, of looking at something that was repeating over and over in your code and generalizing it out to one object, one repeated structure that we can reuse. Interestingly enough, I think this is where OOCSS and SMACs actually kind of shine a little bit more than BEM. They tend to have more of an emphasis on making sure that we don't repeat ourselves in terms of our code. With OOCSS, the emphasis there, I think at least originally, was on kind of performance. We can reduce the bytes over the wire by doing that. We can reduce the amount of CSS we send down the line. And for a big application like Facebook, that's super important. So dry has that benefit, that performance benefit. But dry code also has the benefit, just from a developer perspective, of if we have our code repeated over and over again, it's hard if you want to make changes across that set of objects. If we want to change something to, say, if we want to move all the images to the other side of a media object, or we want to give a border to them or something, that can be challenging if it's defined in multiple places. So we don't want to reduce any places where we multiply our code in terms of the source, if only because it makes it easier for us, but also because it usually ends up with better performance over the wire. And the last kind of theme is organization. And this is a very general theme, but I think that there's an emphasis in all three of these frameworks on how we organize our CSS, and being very conscious about that, and doing it in a way that helps us to write CSS that's otherwise frequently disorganized. All of these methodologies, I think, would emphasize keeping these styles together. In fact, SMAC suggests having either individual files or organizing your files in like folders based on those 5 types: your modules, your layout, your base, your theme, your state. So keeping those all organized. BEM, you'd certainly put each block in its own file. With OOCSS, I think you could do the same thing. And even if you're not putting it in the same file, you're certainly organizing it in terms of where in the CSS it is. Not only because it reduces these problems with the order of CSS, but also because when you go to look for something, you don't want to look between 5 different files, and you have to go to the top of the file and the bottom of the file, and you end up just like Control F and try to search for it. You want to avoid all of that, and you want to be able to have everything in one place. If I'm modifying a single module, I want to know where that is. So yeah, I want to think about how do these architectures improve componentization? How do they fix a lot of the problems that we saw yesterday before we ended up with web components? And what are they all kind of reaching for? What are they kind of seeking? And keep that in mind. I mean, we're going to be able to dive more into the shadow DOM and how that gives us some native modularity. But for a lot of our day-to-day use cases, these patterns are very helpful. And I think it's important to have a sense of these patterns, have an idea of how they work, and be able to implement them in a variety of situations. So I have a few...
Let's stop there so we
Yeah,
can pick it back.
perfect.